We're going to continue our discussion on blood with something that is called blood types. Remember that there are different blood types. So type A, B, AB, O, and something that is called RH, which will give the identity to your cells as either plus or negative. So RH positive or RH negative. We'll talk about the different types of blood types, how you can differentiate between one or the other, and what happens when you transfuse the wrong blood type to the wrong patient. So blood typing. The difference between the different blood types comes about because of surface antigens. A surface antigen is a molecule that is in your red blood cells, and it is used as an ID card for your immune system to recognize cells that belong or that don't belong. So picture a cell that has a glycoprotein or a glycolipid. All right, a glycoprotein or a glycolipid that is right here. The lipid portion of this molecule will be embedded in the cell membrane, and the protein portion of this one will also be embedded in the cell membrane. Now the glyco portion, which we are referring to as carbohydrates, are being expressed in the outer portion of this membrane. Okay, so this will be the glyco, and this will be either a protein or a lipid. All right. So, and we'll go into this in more detail as we take a look at picture, but I want you to know that a surface antigen is a molecule, either be a glycolipid or a glycoprotein that is on the surface of the cell. All right. Now, in specifically to blood typing, these antigens could either be A or it could be B. All right. The presence or absence of this antigen will determine what type of blood type you have. The presence of this antigen will be hereditary. It will be predisposed by your genetic makeup. Let's go ahead and put a check here. The blood types. Remember there is A, B, or RH. We're just gonna dive very quickly here the different types of blood types. So if you have a cell with an antigen that is A, you will have a blood type which is A. If you have a cell that has the antigen B, you have blood type B. If your red blood cell has A and B, you will have blood type AB. This RH is a component or is another type of antigen that may be present. If it is present, if you have RH, that will make it positive. If you do not have the RH antigen, that will make it negative. Here, if you don't have the RH, that will make it negative. So the presence or absence of the RH will tell you whether or not it's positive or negative. Let's move on to the next section. So remember there are two main surface antigens. Surface antigen A and surface antigen B in your red blood cell. And now it is the presence of either one in combination or the absence of them that will give you your different blood types. So for a person that has type A, they will have a red blood cells with the antigen, surface antigen A. A person that has blood type B will have a red blood cell with antigen B. A person that has a type AB will have a red blood cell with A and B. And a person that has O means that it doesn't have any of the antigens present. Keep in mind that here we're not mentioning the Rh antibody, the Rh antigen that we talked about before. Now this Rh, if it is not present, it will be negative. Here this will be AB negative. This will be O negative. Okay. Now the human body is using this antigen as an ID card to find out if the cell belongs or doesn't belong. So your body will produce antibodies against B. Your body naturally will produce the opposite of the antigen that is present on the red blood cells. In this case, it will be against A. Since this cell right here in this third example has both antigens, it doesn't produce any antibodies. No antibodies against these two antigens. Now type O, you will have antibodies against A and B. AB is short for antibody. So just keep in mind the different locations. We'll continue to rehearse this as we move forward. That brings us to the next concept, which is agglutinogens. Now I want you to picture a person, with blood type A. Remember that this person will produce anti-B, right? Because it is trying to kill or destroy anything that is not A. And this person receives a transfusion that is for blood type B. What do you think is going to happen? The immune system is going to attack those now foreign cells that are anti-B. Now your circulating antibody, we're going to picture here the aftermath, this cell with antigen B. This molecule right here will bind onto this antigen, and it will then clump other cells that are B. B, 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 and so on and so forth. And it can bind and up to 10 more red blood cells. So these antibodies that are over here are called agglutinins. And when they bind to this the surface antigen is what we call the agglutinogens. Agglutination means that it clumps together. It can be glued together. So in short, agglutinogens are the surface antigens in the red blood cells that are screened by the immune system. Like we saw over here, this surface antigen was B and it was foreign to this person. So the antibody attacked that agglutinogen. Now that agglutinogen started clumping other cells here. This happened because of the agglutinin, which is the antibody. Plasma antibodies agglutinate or clump foreign cells. These plasma antibodies are agglutinins. Agglutinins. We use agglutination to clump those foreign cells and destroy them. Once they're clumped together, you can hemolyze them. And if they're hemolyzed, you should be careful because you're releasing heme into the blood, and that hemoglobin could occlude renal tubules and cause renal dysfunction. You will also have an increase of bilirubin buildup. Remember that red blood cell recycling cascade, where macrophages come in and engulf the heme, separate the iron and start destroying it into a biliverdin, and then release bilirubin into blood. This is a picture to just show you a little bit of what we were talking about. So there are the different blood types right here: type O, type B, A, and AB. So the surface antigen for type A looks like this. The surface antigen for type B is right here. The anchoring molecule within the phospholipid bilayer could be either a glycoprotein or a glycolipid, either or. Now, a blood type with type AB will have this one and this one. All right, you see how they are the same? Now, type O is not going to have either A or B. All right. Now, remember that type A will make antibodies against B. And type B will make antibodies against A. AB will not make antibodies because it will harm itself. Now type O, because it doesn't have any of them, will make antibodies against both A and B. All right. This is a very simplistic way, and this is what I want you to keep in mind. Now, bringing it into a bigger picture, there is hundreds, actually at least 100 more surface antigens that are within red blood cells. Now, not all of them are as reactive as types A, B, A and B. There are over 100 of them. We focus on them because these are the most reactive. And what I mean by reactive is that they could cause agglutination. Not all of the other antigens could cause agglutination. Remember that we have plasma cells producing antibodies. These antibodies are flowing in circulation, and they have an affinity for either A or B surface antigens, depending on which blood type you have. And if they encounter their affinity, either let's for this example, we're gonna say that this patient has, patient with blood type, we're gonna call it A. So that means his plasma cells will produce antibodies against B. So in circulation we have agglutinins that are anti-B, and if we have agglutinins anti-B, it will attack what type of cells? Cells with either type B or cells AB. And when this agglutinin binds to B, B is the agglutinogen, all right? This is the surface antigen. Then other molecules will start binding, and that is why it clumps. All right, and this will lead to further issues. This is another picture to describe some of the same concepts. If you have blood type A, your red blood cell has a surface antigen against A, surface antigens A, and you will produce antibodies against B. All right. If you have blood type B, then you will have surface antigens for B, and you will produce antibodies against A. If you have blood type AB, you will have surface antigens for both, and you will not produce any antibodies against against B or A, because otherwise you will attack yourself. And type O means that you do not have any surface antigens, therefore you will produce antibodies against both A and B. Here you could deduce that there is something that is called a universal recipient and a universal donor. All right, universal recipient means that you can receive any type of blood. All right, which one would that be? That's correct. That's correct. That would be AB. So AB, because he doesn't have any type of antibodies, you could give him A or B or O, because he won't have any antigens against it. When you are transfusing, from one patient to another, you are just transfusing the red blood cells. You are not transfusing the antigens. So let's make it a person here. It has this person maybe A, and it will produce what type of antibodies? Antibodies against B. So anti-B. All right. Now we have another person that was in a car accident. Another person that was in a car accident and needs blood. This person has blood type AB. So he doesn't have any antibodies. Antibodies, none. So he will be able to receive type A. Now you have to keep in mind that the transfusion doesn't include the antibodies that this person is making. It is only transfusing the red blood cells. So because we're only transfusing the red blood cells, it will be just fine. All right, you won't transfuse the antibodies, otherwise you won't be able to match anybody with anybody if you were to transfuse the antibodies. So you just transfuse the red blood cells. Now continuing to the discussion of transfusion, who will be the universal donor? So the universal donor will be type O. And the reason for that is because there is no surface antigens that the person that is receiving it that could be attacked. So if we were to transfuse just the red blood cells to a person with type A, will those red blood cells be attacked? The answer is no, because there is no B antigen on this molecule. Now can we transfuse type O to type B? The answer is yes, because there is no molecule A or B, no surface antigen A or B on that cell. What about type AB? Can we give them O? Yes, because there is no antibody within the person that is receiving the type O to attack any of the surface antigens. Now, going deeper, remember how we mentioned another surface antigen, RH? So RH is another, it was first found on the rhesus monkey. That is why it is denominated RH. Now, RH can either be positive or negative. So if the antigen is present, if the RH antigen is present, you are deemed to be positive. If you don't have the RH, you are deemed to be negative. All right. Now, this is different than the other antigens because we are not creating antibodies naturally against a RH if you are positive or if you are negative. All right. This will be a key concept. This blood will never have RH antibodies. And we'll continue here. So let's dive into this a little bit deeper. So we have a person with blood type A and RH. So this will make it blood type A positive. All right. Now, what antibodies will this person make? This person will make antibodies against B. Will it make antibodies against RH? No, it will never have antibodies against RH. If it were to have antibodies against RH, it will attack itself. So no RH antibodies. Now let's take a look at a person with type A. And because we're going to miss the RH antibody, this will be a negative. Now, what type of antibodies will this person produce? This person will produce antibodies anti-B. And will it produce anti-RH? No, it depends. It will only produce antibodies against RH if there is exposure to that antigen. So these antibodies are produced by plasma cells. Antibodies are plasma cells. So we have B cells. Let's go ahead and go just to give you a clean picture. We have look a lymphocytes divide into 3 cells: NK cells, B cell lymphocytes, and T cell lymphocytes. Now these B cell lymphocytes further divide into plasma cells, and it is these plasma cells that release antibodies. Now these antibodies are targeted, right? Now these plasma cells have to learn what to target. In order to create that molecule, to have a higher affinity for that molecule, for that surface antigen, it has to learn it. So this is when we talk about acquired immunity. So if these plasma cells are taught or they learn about the Rh, all right, if they are exposed to Rh positive through a blood incident, let's say there is cross blood contamination, you are transfused with Rh positive, or this patient was transfused with Rh positive, or you are the mother of you are the mother with a blood type A negative, and you're exposed to a fetus that is Rh positive, then those plasma cells will learn and eventually will produce Rh antibodies against Rh. But remember that this doesn't happen immediately. You won't have it unless you're sensitized. And when we talk about sensitization, we talk about the learning of that molecule. This is diving into this idea that the Rh antigen is present and antibodies are only created if exposed. This is alluding to a specific disease, and is the hemolytic disease of the newborn, or HDN. All right. So this happens when the mother is Rh negative. All right. So it doesn't have the Rh, but remember that because she hasn't been sensitized, she doesn't have antibodies against Rh. And then the baby is Rh positive. How can this happen? Well, the father will have a Rh positive blood. So because these surface antigens are determined by genetic inheritance, the baby ended up with Rh positive in this case. So the placenta, in this case, doesn't allow for red blood cells to cross from one side to the other. Okay, there is an exchange of oxygen between a mother, we'll put it here, mother, and we'll put it baby or fetus. So the fetus blood, the red blood cells will come over here and they will take the oxygen away from the red blood cells of the mother. So there is just oxygen exchange and gases exchange, oxygen and CO2. All right, but the actual red blood cells don't cross. So the mother during this placenta bilayer doesn't really get exposed to the red blood cells with Rh. This baby will have, let's say for instance, A and Rh, and the mother will have just A. What does cross the placenta is antibodies. Antibodies are able to cross from one side to the other. So the mother hasn't been sensitized. Let's move on to the next picture, and we're building up onto this case. So for some reason, there was cross or blood contamination, either be because there was bleeding, there was a delivery, there was blood that crossed from the baby into the mother. Now the mother has been exposed to the Rh positive. Those plasma cells learned about it, and they don't make the antibody. It takes some time for it to start producing antibodies. and then after that it will start making Rh antibodies against Rh. So exposure of those red blood cells antigens of Rh when during bleeding, either be because of placenta abruption, there is bleeding and there is cross contamination, that teaches the mother or the plasma cells within the mother to start creating antibodies against Rh surface antigen, which she doesn't have. So it wouldn't affect her because she doesn't have a Rh surface antigen. She was Rh negative to begin with. Now, this won't be a problem the first pregnancy, but it will be a problem on the second pregnancy. About 6 months after delivery, the mother will be sensitized. So the mother is now carrying antibodies against the Rh antigen. So although the first infant wasn't affected because she didn't have the antibodies and it took time for her immune system to learn it, it is her second pregnancy that may be at risk, because remember that those antibodies will cross the placenta. So in the next pregnancy, let's say she ended up being pregnant again. She's just still, let's just say she was A and she was negative, A negative, so she didn't have the Rh antigen. But remember that she now has antibodies against B and antibodies against Rh because she was sensitized. Now during this placenta, there will be a crossover of antibodies. All right, although the red blood cells are not crossing from one side to the other, the antibodies are, and they will hemolyze the blood cells of the baby. And that is what we call hemolytic disease of the newborn. The problem here is that those hemolyzed cells will lead to a high buildup of hemoglobin and bilirubin buildup as well. And as the bilirubin is building up, that will accumulate in the baby's brain, and that will cause a neurological defects. So as we move forward, keep in mind that there are different blood types, but the most reactive are A, B, and Rh. Although there are other surface antigens that are out there, we oftentimes focus on those three only: the presence or the absence of the A, B, or Rh surface antigen. What is blood typing? Blood typing means that we need to find out what type of blood you have to avoid some of these transfusions and reactions, as your plasma antibodies meet a specific surface antigen. So remember that your plasma cells are releasing antibodies that once they meet with the agglutinogen, they become, the agglutinin, which is the antibody, meets with the agglutinogen, which is the surface antigen specific to that type of blood. It will cause the agglutination or the clumping of those cells, and eventually they will hemolyze and rupture because of other inflammatory factors, complement molecules. But we want to make sure that the person is compatible. If it is not, a lot of issues will occur. So how can we differentiate between one or the other, or what blood type you have? So during this antibody blood typing exercise, we're going to inject anti-A antibodies into a blood sample. And if we see agglutination, we will find that there is a surface antigen A into this blood cell. Okay. So anti-A, when applied, there is blood clumping, so there is. Now we don't see any blood clumping when we apply to this sample number 1, sample number 2, sample number 4. So when we apply this anti-A, we see agglutination. So we know at least we have blood type A because it has that surface antigen. Now, if we apply anti-B, but we don't see any, it means that at least it doesn't have B type. We do see some agglutination here within anti-D, and anti-D refers to the Rh antigen. Means that if we have agglutination, at least we have the Rh presence. So this will be A positive. Now within this one, although it seems a little darker here in the center, it doesn't seem as agglutinated as the other ones. So since it has anti-A and there is no agglutination, we're going to say that there is no agglutination here. Then it doesn't have A. Then it should have something else, but it may not have A. Now we injected with B, and you see that there are clumps. So we know that there is at least B. Now we injected with anti-RH, and there is agglutination. So here we have B positive. Now if we injected with anti-A on sample number 3, here we should have at least antigen A. Here we should have at least antigen B because we're injecting anti-B, and here we have anti-RH. So we have A, B positive. Here, no agglutination. Here, no agglutination, and here no agglutination. So if you don't have agglutination, then there is no A, then there is no B, and there is no RH. So this will mean that this is O negative. I wanted to briefly discuss some of the mechanisms by which you inherit your blood types. First, remember that there are over 100 types of surface antigens related to blood. We're focusing only on the types A, B, and RH. All right. Now, whenever you express or you show that surface antigen, is because you inherited from either your mother or your father. Well, this will be for mother and this will be for father. So if your mother were to be type O, all right, and your father were to be type B, likely you may express the baby may have type B blood. Because you inherit both, all right, the other one will be type O, but you are going to express this. So even though it is O plus B, O means that there is an absence of antigens, so you are just having an expression of the type B antigen on that surface of the red blood cell. As we get into this a little bit more technical, know that the mother is not just type O, it's probably just OO, and the father, we can assume that is BB in this case. So the mother received one of them from the mother and one of them from the father. And the same for the father. He received one from the mom and one from the father. So if type, if we were to do the different combinations for the different possibilities that this baby could be, you can only get a B. All right. Now, in the next example, we're going to do a little bit different, and we're just going to try to explain hemolytic disease of the newborn with a mother that has type O, all right, and a baby that has type AB. This will be highly abnormal because there is not a way in which a mother can have a baby with type AB. Let's take a little bit why. If you were to have a mother with type O, it means that she has to have both O's. If she were to have a presence of an A or B allele, it will be expressed down. So, and then the father were to be AB, the different combinations may give you OA, OB, and then the baby might either be type A or type B. So the baby can only have A or B. There is not a world in which you can have a mother with type O, and also have a baby with type AB. Again, seems to be a little bit complex. You're not required to know this, but this is some of the very simplistic way to look at the mechanism by which blood types are inherited. Quickly, you could have a mother with type O have a baby with type AB if the baby was created in the lab, right? I mean, if you were to have the baby created in the lab, then the blood type is not related to the parents. All right, thank you, sir. Thank you very much. We'll go on to the next section. So just in summary, remember that blood types are based on your genetic makeup, and there are different blood types: A, B, AB, and O. And in addition to that, you may have an additional positive or negative sign to it, depending on whether or not you have an Rh surface antigens. Now, the surface antigens are basically carbohydrates attached to a lipid or to a protein, and we say that they are either glycolipids or glycoproteins. The presence or absence of these will determine what type of antibody you will create. So if you have type A, you will create anti-B antibodies. If you have type B, you will create anti-A antibodies. Now, if you have Rh, you will be positive, and you will never create antibodies against Rh, otherwise you will hurt yourself. However, as we take a look at hemolytic disease of the newborn, this happens in mothers that are this happens during pregnancies where there is incompatibilities between the mother's blood type and the baby's blood type. Oftentimes, we focus more so on the Rh antigen incompatibility because it is highly reactive. So it is the one that leads to the most problems. However, you could have an incompatibility for types AO and AB. So let's take a look at this into detail. So we talked about a mother with Rh negative does not have antibodies against Rh unless she's sensitized. She, for some reason, underwent a first pregnancy with a baby that was Rh positive. And it was Rh positive because the father happened to have Rh positive. So that is why the baby inherited that. So the mother, during the time of delivery, there was cross-contamination, and plasma cells ended up learning about Rh, and then about 6 months later, it started creating antibodies. Now the mother has been sensitized, and now she's still Rh negative. However, she has antibodies against. She doesn't remember that she's Rh negative, so she doesn't have Rh surface antigens within her red blood cells. However, she's now making antibodies against Rh. So in her second pregnancy, those antibodies can cross the placenta, and if the baby is still Rh positive, it will affect the baby, leading to the hemolysis of red blood cells. Now let's take a look at a incompatibility between type O and AB. Let's say the mother is type O, which and is O negative. It's actually let's do O positive. All right, and so she will have antibodies against A. We'll just put in here the Rh, A, and B. Now she will never make antibodies against Rh because she has the surface antigen. She will be attacking herself. And she has a baby that has type blood AB. All right. Now these baby's red blood cells will have A and B. Now there may be a cross of these antibodies and also lead to a problem with hemolytic disease of the newborn. Now this type of a cross reaction here is not as severe as it is with the Rh factor. The Rh reaction is highly reactive. This is still treated. All right, but so you can see that there can still be a hemolytic disease of the newborn with just a blood type, not with other blood types such as A and B, not just Rh. This is still treated by infusing the baby with the blood cell types that are not attacked, and eventually those other red blood cells will still be transfused out. This is very complex, and this is just a simplistic way of looking at it. So just keep in mind that there are different blood types, and it's important for us to determine the right blood type before transfusing anybody. Otherwise, there will be clumping of those cells and they will hemolyze. Thank you, and then the next episode or the next video will be about white blood cells.